This is the third video on Mr. Loftus's National 5 Maths Percentages series. Make sure that you've watched the first two, the first one being on revision of basic percentages, the second one being about percentage increase and decrease, and appreciation and depreciation, and profit and loss. This third out of four videos, I should say, will be on compound interest. So the learning intention of this video is working out compound interest. So let's take a quick moment just to explain what compound interest means. So the word compound essentially means if something is repeated, particularly if it's repeated over and over again. So if you compound something, in this context at least, it tends to mean if something's happening repeatedly over and over again. Interest, in this case, we usually talk about financial interest, monetary interest, okay, and that usually refers to an incremental increase in value over time. So in the examples that we're going to see today, we're going to be talking about savings. So if you have, say, a savings account with a particular interest rate, we should have heard those terms before. If it has a particular interest rate, that interest is basically an amount of money which is added on to the amount that you have in your bank at that time. Now, interest can be a good thing or bad thing, depending on what position you're in financially. If you have money in the bank, if you're saving it, a high interest rate, a large percentage interest is a good thing. We want a high interest rate if you have savings. If you have debt, i.e. say a mortgage or a credit card or a loan, you want a low interest rate on that, because the interest is the incremental increase in the value of that. So either in the value of the savings or in the value of the debt. Okay, so if you have, say, £10,000 in savings in the bank and a high interest rate, the bank adds to your amount of savings every year. Whereas if you have £10,000 in credit card debt with a high interest rate, it means that the bank is going to add money on to the amount that you owe, the amount of debt that you have in your name. So depending on what financial position you're in, interest can be a good thing or it can be a bad thing. In general, you should aim to be saving rather than accumulating debt. So in general, we want a high interest rate. At the moment, interest rates are the lowest they've ever been because of the current financial situation, but that's maybe something we could do as a class discussion. So again, for this video, you will definitely need a calculator. You could have got by without a calculator in the last couple of videos if you are good at multiplying, dividing by 100 and different numbers. In this video, you will definitely need a calculator to do this method the sophisticated way, which we're about to see. So, our first example in this video, we have the example that we were just discussing. So Mr. Loftus opens a savings account, so a bank account where I'm saving money, with an interest rate of 3% per annum. Okay, now let's just unpack what that means. Per annum, annual, anniversary, per annum means per year. 3% is a particularly high interest rate for a savings account in the UK. If you have a normal bank account, it will usually be somewhere between 0 and 1%. Things like ISAs and things for saving if you're buying a house and stuff like that usually tend to be about 2.25%. At the moment, unfortunately, it's 0.01%, which is the rate set by the Bank of England in the UK. But for this example, let's go for a generous 3% per year. So he deposits £2,000 in the account in 2017. So deposit means you're putting in. If you're taking out, it's called a withdrawal. So deposit means put in, withdrawal means take out. Calculate the compound interest on his investment by 2020. So 2020, we're talking 3 years later, and we want to calculate the amount of interest that I've essentially made on that investment. So if I put £2,000 in, by 2020, 3 years later, how much interest have I built up in that time? Because remember, as we've just said, interest, the bank adds on an amount to whatever you have in the bank. So I'm getting 3% every year on my £2,000. So how much do I have after 3 years? Now, there's two ways of doing this, the easy way and the hard way. Now, if we're talking about 3% per year, we could do this the long way, which is probably the way you're thinking of, which is, well, after 1 year, let's find 3% of 2000 and add it on, which is easy enough to do. 1% would be 20, so 3% would be 60. So after 1 year, it'd have 2060. Then do 3% of that number, so 1% of that would be £20 and £60, times it by 3 would be £61.80, add it on, so on and so forth. Now that's fine if you've got a reasonably easy percentage. We've got 3%, that's a nice whole number, 2000's a very whole number, and it's only over 3 years. What if I had an interest rate of 3.12% on £2,540.75 and it was over 20 years? That would take far too long. Okay, so we turn to our knowledge of percentages and try and do this a more sophisticated way, which is the following. So let's decide if we're increasing or decreasing first of all. Well, we've just discussed that. If we have a savings account, okay, with an interest rate, that means that we're adding. Okay, so we start with 100%. How much are we adding on each year? Well, it's 3% interest rate, so we're adding on 3%. Okay, not a trick question. 100% plus 3% is 103%. Okay, now what we're going to do is we're going to express this number as a decimal. That decimal number is going to be called our multiplier. Okay, how do we convert a percentage into a decimal? Well, think about something like 50%. 50% as a decimal would just be 0.5. How did we get there? We divided by our magic number, which is 100. Okay, so what we're going to do is we're going to divide this number by 100. Okay, again, not a trick question, that's a nice easy bit. 103 divided by 100 is 1.03. Okay, now I have been a little bit sketchy with my equal signs here. Technically that's not equal to this part, so I've changed it to an arrow, and 103% divided by 100 should be 1.03%, so we've changed it to an arrow because we're going to use this 1.03, not a percentage, and this thing is called my multiplier. Okay, different textbooks and things like that might call it something different, but for the purposes of this, I'm going to call this our multiplier. Now, if you remember, we said that the long way was finding 3% of this and adding it on, then 3% of that and adding it on, 3% of that and adding it on. Well, look how quick this way is. If we now use this magic multiplier here, if I take my £2,000 that I started with, and it's called a multiplier, so I'm going to multiply by that number, 1.03. Okay, we said that after 1 year we should have, if you remember, £2,060, because 3% of 2,000 is 60, add it on, gives me 2,060. If I turn my calculator on, 2,000 times 1.03, as if by magic it gives me 2,060. Hopefully we can see that on the display there. Okay, so that tells me that if I multiply by 1.03, what my calculator is actually doing is it's taking that number and it's actually adding 3% on, which makes sense because if you times it by 1, that keeps it the same, and if you times it by 1.03, it's including the extra 3%. Okay, now that would be us finished. That 2,060 would be us finished if it asked for after 1 year. Okay, but it doesn't ask us for after 3 years. Okay, because 2017 to 2020 is 3 years. So, well, what could I do? I could write down 2060, then I could times by 1.03 again. Now, that would also work, but we're mathematicians, we want to do things as quickly as possible, so I could just times it by 1.03 again, like that. And that will give me the same thing as doing it the long way, so times it by 1.03 gives me this number, 2,121.8, which is the one we talked about. And if I want to do it again, times it by 1.03 again, and that is going to be the amount in my account after 3 years, which is 2,185.454. We'll round it at the end. Now, that's a pretty quick way of doing it. That's cut out a lot of working, but as I said, we're mathematicians, we want to keep it as efficient as possible, and there's an even quicker way of doing it. Now, if we just cover up that 2,000 there, and I just said to you, let's take 1.03 multiply it by itself, and multiply it by itself again. We have a special way of writing that. Well, if you multiply something by itself, that's called squaring, and if you multiply it by itself again, that's called cubing. In other words, raising it to the power of 2, raising it to the power of 3. So let's actually just write it that way. 2000 multiplied by 1.03 to the power of 3. And that, let's check our calculator, is going to give us the exact same answer. 2000 multiplied by 1.03, little power of button if you have this calculator is here, to the power of 3 equals, voila, gives us the exact same answer. Okay, so that's going to give us 2185.454. Remember the context of the question, this is about money. We're going to put a pound sign, 2185 point, we've got 454, let's go 2 decimal places. 4 is less than 5, so we're going to round down, so pounds 45 pence. Now, we're going to recap that process in the next example, but let's see if we've actually just answered our question first. Okay, we were asked calculate the compound interest on his investment by 2020. What we have here is how much money I would have in the bank by 2020, not the amount of interest. So how would I work out the amount of interest? Well, take the amount with the interest and take away, subtract the initial amount, okay? Which is easy enough to do. We've got 2185.45, take away 2000. So that means my interest, my compound interest, I should write, is just going to be my amount with the interest, subtract my initial 2000, which is going to be £185.45. Okay, if you need to pause the video at this point to check over those notes, you can, and if you're struggling, please ask questions about that first example, but hopefully it will become clearer after the second example. Okay, so here is the second example. Now, with compound interest questions, they usually tend to be about money. If it's compound interest, strictly it should be about financial interest in the bank. But a really interesting application of this is some real life stuff, which is more like population modelling. Now, if you've been watching the news recently, you should have heard the word modelling a lot, talking about the current pandemic and things like that. Mathematical modelling has been in the news a lot. Now, this is a very simplified example of it, but it might lead to some sort of broader discussions that we could have about modelling. So, again, keep things real life examples. These are up-to-date figures as of today. Today is Monday the 18th of May. Now, at present, the number of patients in hospital with a virus in Scotland was 1,427. Okay, now I have taken liberty with this figure here, but I'm just making it an estimate based on the recent falls per day. So, as expected, this number of patients in hospital will fall by 2.4% per day. How many fewer cases will there be after 20 days? Now, that's obviously an average. It doesn't fall by 2.4% every day, but for the simplicity of this question, let's take it as that. Now, you might be thinking, how on earth is this a compound interest question? Where's the money? Where's the interest rate? But if you look at it simply, it is the exact same. It's just a slightly different context. So, let's look at how we started the last question. You always start with 100%. Okay? Now, in the last question, we had an interest rate of 3%, so we added on 3% because interest means that our number is going to grow. But in this context, it is expected the number will fall by 2.4%. Fall means it's going down. So instead of adding on that percentage, we're going to subtract that percentage. So let's subtract 2.4%. Okay, what does that leave us with? Again, this isn't the difficult bit, it's not a trick question. 100 take away 2 is 98. Take away a further 0.4 will give me 97.6%. Like so. Okay. Now, again, let's convert that into a decimal because that's going to be useful to us in this question. How do we do that? We divide that figure by 100, and that then gives us 0.976 here. Now, whatever comes up in your calculator there, you'll leave it as that. You do not round that to 1, 2, 3, or any number of decimal places. You keep it exact as what it is, okay, because that is your percentage decrease, essentially. Okay, you need to keep that exact. If we just rounded that to 0.98, that would mean it was just fallen by 2%, but we need 2.4%. But now, once they've done that, it's actually just as easy. Okay, in the last example, we started with our £2,000. Here, we're going to start with our 1,427 patients. This is our multiplier, remember, our multiplier. Okay, so we're going to multiply by that number, 0.976. You might have even heard about things like this in the news recently. This is very similar, actually. I don't want to get too bogged down by this in the middle of the video, but this is similar to the R number that you'll have heard on the news, which is the reproductive rate of the particular virus that we're talking about. It is not a rate, I should say, actually. It's the reproductive number. Okay, and basically, how does that relate to this question? Well, if the R number is between 0 and 1, it means that the number of people infected is going to fall. If it's greater than 1, it means it's going to multiply up the way, it's going to get larger. Okay, so in this example, we're talking about a fall of 2.4%, which correlates to a number less than 1. If it was increasing by 2.4%, then we would have 1.024, which is an increase. Okay, so that's a wee bit of a side. We don't want to get too bogged down with that. Let's go back to constructing our calculation here. So we've got the 1,427 patients multiplied by our 0.976. And what we did last time was we did to the power of 3 because we had 3 years. But now we're saying it falls by 2.4% per day. How many fewer cases will there be after 20 days? So we're going to raise it to the power of 20. And that will always be the same, no matter what your time units are. If it's an interest rate per year, number of years, the increase in something per month, number of months, so on and so forth. This will always be the power that you raise it to. Okay, and you can really see the use of this method compared to the long way, which is, say, take away 2.4% one day, take away 2.4% again, take away 2.4% again. That would take you forever if you're doing it 20 times. But here, we just need to do one calculation, and we've got a calculator to do it. 1,427 multiplied by 0.976 raised to the power of 20, hit the equals button, and what do we get? We get 877.85. Okay, we've got 002. 62, we'll just put that in for completeness just now. Okay, certain context of questions you will need to put down all your decimal places and then round it, so let's do that just now. We've got 877.85 to 2 decimal places, but we're talking about the number of patients here. Okay, so let's keep that in mind, that we probably will round that further in a minute. Now, let's check the context of our question. It says, how many fewer cases will there be after 20 days? Does that mean there's 877.85 fewer cases? No, it doesn't. It's telling us that the number of cases will fall by 2.4% per day. So this is the number of cases after 20 days, not how many fewer cases there are after 20 days. So to work out that, we need to do the same thing that we did last time, which is take our original number of cases in hospital, 1,427, take away how much we have now after 20 days. So we've got 1,427 subtract 877.85 equals, so essentially our fewer cases is 549.15, and we'll round that to the nearest whole number, which would be 549. So we have 549 fewer cases after 20 days. So again, another long video there with a lot of information, but hopefully useful information. And again, just 2 examples there, but there's plenty of examples that we're going to try together. If you have questions on that, please ask. And yeah, we'll see a couple more examples on interest and other kind of population modelling questions. The next video will be on working backwards, then one on past paper questions, and that will be us finished with the percentages unit for now.